Hi guys, and welcome back to another video on Upper Meridian Passages. This time we'll be looking at the Upper Meridian Passage for Venus. So the question states the following. It says find the GMT and the zone time for Venus at Upper Meridian Passage on the 22nd of June on 1979. So again, the ship is stationary, so there won't be any vectors to work. And again, I've given the information for you there. So that's all the information that would be given in the question. So the date of the ship is the 22nd of June. The DR latitude is 64 degrees 12.0 minutes north. The DR longitude is 67 degrees 39.0 minutes west. And the body that we're observing is, of course, Venus at Upper Meridian Passage. So in the last video we said that we know that the ship's date, because it's the ship's time that we essentially want, that zone time there, so the date of the ship must be the same as the date in the question. So the date of the ship there must be the 22nd of June. Okay, so what we're going to do is we're going to enter the almanac on the 22nd of June, and we are going to find the time of Upper Meridian Passage for Venus on the 22nd of June at the observer's local meridian. So plus minus LMT on the 22nd of June, and that will give us a time of 10:47. So on the left hand page in the almanac, right in the bottom right corner, it gives us there for Venus. That date there, the 22nd of June, we'll be covering that time. We'll be covering those 3 days. In some cases, we could interpolate a day ahead or a day back, but that shouldn't make too much of a difference. In this case, it won't make a difference in any case because it's the day in the center of the almanac. So 10:47 will be the time that we use it. So that is the local plus minus meridian time for Upper Meridian Passage. And this will be at which meridian? We've got a western longitude, so this is at the meridian 67 degrees 39.0 minutes west. So we're going from that meridian to Greenwich, so therefore we will be adding the time because Greenwich is at a later time. So we're going to take this longitude of ours, the 67 degrees 39 minutes west, and we are going to divide that by 15. Okay, so we'll convert it into a decimal, and we'll divide it by 15 because it's 15 degrees per hour, and that then will give us a time increment. So that time increment there is 4 hours and 31 minutes. That of course will be added to our LMT, and that's then going to give us a GMT, an approximate GMT for Upper Meridian Passage of Venus on the 22nd of June. The date won't change, and that will then be at 15:18 approximate. So once we've got this approximate time, from there we now need to apply our zone difference. So our zone difference, in this case, we are in time zone R. So if you're not sure, you can always look at the longitude there and work that back. So we're actually in time zone R. We're more or less actually in the center of that new time zone. That's why we actually got more or less 4.5 hours over here. So we've just gone over with the clock setting it up to 5 hours behind GMT for time zone R. So in this case, we will be applying a 5-hour difference in. So we're going from GMT to ship time. So we're going back in time in a westerly direction. Therefore, we will be subtracting 5 hours, and that of course will give us then a time, an approximate ship time for Upper Meridian Passage of 10:18 on the 22nd of June. So once we've got this, we can now basically go into the almanac and we can start working on our hour angles here. So we know that for Upper Meridian Passage, for anybody, the LHA will always be 0 or 360. So in this case, we've got a western longitude. So we're going from L to Greenwich, so from local to Greenwich in an easterly direction, and therefore we will be adding that west longitude. Okay, so we're going to start at 0, we're going to add the west longitude, and now this animal over here will basically be new to the Venus calculation. So it's unique, specific to this calculation. You'll only see this when we're dealing with Venus, and that is of course the V correction. So when we do a standard site reduction, or in a Mark Center, for instance, what we do is we usually start at GHA, then we get the increments, then we apply longitude, and then lastly we get this V correction which we basically apply. So that V, that negative minus 0.8, that is read from the almanac at the bottom of the page for the date that we're using, which is the 22nd of June. So it tells you there that V equals minus 0.8. Now when we went from Greenwich, from a GHA, in order to find LHA in a site reduction, we applied that negative over here, so this became minus, and then we basically took an increment, an 18-minute increment in the yellow pages at the back of the almanac, the 18-minute increment for that 0.8 V, which in this case is 0.2. So if you go into the yellow pages at 18 minutes, you will find that 0.8 becomes 0.2. But note, here's the catch. Even though V is negative, because we are now not working from Greenwich to LHA, but we're actually working backwards. So we're working from LHA going backwards toward Greenwich. So that negative V will become a positive value. So that value now will be added to the LHA in order to get our GHA for Upper Meridian Passage. And that will then be 67 degrees, 39.2 minutes. So from there, it's straightforward again. Now we go back into the almanac, and this will of course be on that 22nd of June, so we'll always be using this date over here. So we go back into 22nd of June, and we find the GHA, the tabulated GHA, that is closest to 67 and also before 67, so lower than 67. And we're basically going to read a value there of 63 degrees, 17.8 minutes. And this tabulated GHA can be found on the 22nd of June, of course, and now that will be at 1500. So that 1500 again correlates with the 1500 over here, so that just again shows us that we are actually still on the right track. So if that's GHA, actual GHA, and that is the tabulated GHA, then that means that the increments over here, when to apply, we subtract those two there, and that then will give us an actual increment of 4 degrees 21.4 minutes. Okay, so this 4 degrees 21.4 minutes will now be applied to the total change. So it's going to form a fraction along with the total change in our angle between 1500 Zulu and 1600 Zulu on the 22nd of June. So that's going to give us a difference there of 14 degrees 59.2, and then that fraction, that 4 degrees 21.4 divided by 14 59.2, that fraction will give us a time increment, and that time increment is over here, that is what we will be applying. So the time increment will be added, and that's then going to give us a GMT, an actual GMT to the nearest second of 15:17:27, and that will of course be Zulu time. So from there we can simply finish it off by again looking at the zone difference here. So we're going from GMT towards the ship to a western time zone, so therefore we will be going back in time, so we need to subtract again 5 hours, and that will then give us a ship time on the 22nd of June still at 10:17:26 in the morning, and that will of course be in Romeo time. So this is a calculation for Venus. This is what it would look like if the vessel is stationary and we need to get a time for the Upper Meridian Passage of Venus. So I hope you guys can make use of this one, and in the next set of videos we will be looking at how we're going to do and approach a Lower Meridian Passage calculation.